Two examples of wave monitoring programs. There are several wave monitoring programs that are usually run at the national level that provide data that you can find on the web. And a first example may be given by the Queensland government. And let me see if this link is still working. I think yes, yeah. And this is a program that explains how data are collected and also puts data available. This is the first example that I give to you to explore if you want. And this is a second link. I think this is a map of the sites. It's in Australia. And if you click on the site, you get more details. And I think you should find also the data here. And there is another link somewhere of a wave monitoring program here, NOAA. And here you can find the data. And here I took the data for the exercise that I'm proposing to you next week, and then I modified them a little bit because they were a little bit difficult to use in the form. And the problem with the data in general is the format. So when you download them, sometimes you need softwares in order to read the data, because given the amount of data that is very huge, often these agencies use to compress the data in a way that in many cases you need a software, a dedicated software to extract them. So basically when you deal with databases, keep in mind environmental databases, the problem is not to find the data to download them, the problem is to handle the data. Because sometimes you get a huge amount of information and you need dedicated software to use them. And this is the main problem usually when we try to download information, environmental information from the web. This is the main problem that I have when I propose thesis to students, applied thesis, and very often they are given data in a format that is difficult for them to use. Because they need to be interpreted and extracted, and this is something that from an operational point of view is not easy. And this once again highlights the opportunity for you to get skilled on the PC, and to get skilled means also to know what is a commercial software, what is a public domain software, and how to use these different types of software that in many cases you need to use when you want to deal with data. Okay, and here I am providing a couple of examples. One example specifically referred to Italy. In Italy, the collection and management of environmental data is mostly done by an institute that is called ISPRA in Italian, ISPRI, which is based in the Lombardia region and takes care, as I said, at the national level of the collection of environmental data. This does not mean that any kind of environmental data in Italy is collected by ISPRA. One thing that you should be aware of is that in a country in general, you may have several agencies that are in charge of environmental monitoring. And the interaction between these agencies, among these agencies, sometimes is not clear to understand. And there are always administrative regions that provide a motivation for the presence of overlapping tasks, overlapping responsibilities. But to understand these reasons and to understand what are the responsibility actually is not an easy task. Keep in mind that when we are students, we are told that there are agencies collecting data. So we think we assume that for any kind of data there is a unique reference. Like I need wave data, okay? I assume that there is ISPRA collecting them in Italy, and then I just have to go to ISPRA. But actually this is not the case, because there are also, for instance, shipping companies or agencies that manage harbors that individually collect data for their purposes. And sometimes they get data from a sensor that is placed very close to the sensor of ISPRA. But they don't share the data. They don't share the data because we don't have a national structure that is in charge of collecting all the data related to environment. And keep in mind that such a structure would be really demanding in terms of resources, in terms of organization. And this happens not only in Italy, but in general. Keep in mind that the longer the history of a country, and the more complicated the administration is. So, if we talk about water in general in Italy, the history of Italy, you know, is very long. It dates back to the Romans, etc. There are institutions, I'm not saying that they were created by the Romans, but more or less, this is what I mean to say. There are institutions that are in charge of managing waters, including the seas, that were created hundreds of years ago. And then they undergone several administrative changes from several separated countries in Italy to a unique country that was born just 150 years ago. So, well later, after these institutions were created, and these institutions undergone these several changes, and sometimes the interaction between the national administration and these individual institutions developed in a way that is not fully synchronized. And therefore it's not easy to understand who is collecting what. Okay? So for instance, I'm quite experienced in the river flow data. There are national agencies that collect them. There is a national company for the hydropower production called Enel that collect this data. There are reclamation consortiums, Consorzio di Bonifica, Consortium for Irrigation, water boards that collect this data. And they don't share the data, not because they don't want to, but they are not prepared to. And therefore, to understand where the data taken is not easy. Okay, going back to our problems, We have one source of information related to waves in Italy, that is ISPRA. And you can find here, you can find a map of the sensors. They are mainly buoys, and here is the location. They have a code. And here is a description of the buoys that they use. And the parameters that are measured, wave height, or here you see peak period, mean wave direction, peak mean total direction, mean wind waves direction, etc., water temperature. And here you see an example of statistics that they provide. These are pictures about wave climate. And you see that there are the four cardinal directions with, for each season, a bar showing wave direction. Different colors reflect different wave heights. So, yellow means higher heights, blue means lower heights. So, for instance, from the top left picture, you see that there are two dominant wave directions during summer, with the higher wave heights. So they provide these statistics, and they can be downloaded. I'm not sure if they can be downloaded for free. Okay? Usually some data can be downloaded for free. Usually there are several data that can be downloaded for free for non-commercial purposes. So for instance, for doing a thesis, they can be downloaded, but one has to ask permission for doing that. So you need a letter from the university on headed paper, and authorizing you to download the data. And here you can see some data on extreme waves in Italy. And you see that in Italy, we have not oceans around Italy. We have a closed sea, the Mediterranean, and an even more closed one, the Adriatic. So if you look at the wave height, we don't have really such big waves. And here you see that for the return period of about, do you know what is a return period? Okay, good. For a return period around 10, 20 years, you see wave heights of 6, 5, 6, 9 in Sardinia, but they are the highest. And in Sardinia we have the highest waves because Sardinia is located in proximity of the larger part of the Mediterranean. The Mediterranean, where Sardinia is located, is very large, so the fetch is more extended. The fetch is the part of the ocean that is exposed to wind. Sicily is quite close, the free sea, Sicily is very close to Africa, and therefore you have the height of the waves that is a little bit lower. Okay, this is just to give you some information. This is not this is not a topic that is a subject for the exam. It's just to give you an idea. Okay, let me turn now to the next lecture, which is, just 1 second, I need to look my website, what is the number, the address. Okay, it's 199. Okay, 152. Saltwater intrusion.
Excuse me, I have a question about the last topic, monitoring.
Yeah.
You specify the different classes of the wave recorders. I want to know that in all the cases we have discrete data after we collect the data from the sensors, or some of them can record the data in a continuous form, because we have different, in the books or in the internet we can see that the records are continuous, but I think there are a lot of points that may be connected with a line that we can see.
What do you mean by continuous? You get numbers, correct? You get tables.
Yes, I think the sensors collect the data in an interval time, not in a continuous form. For example, after 2 seconds or 1 second, they record the wave height.
Yeah. Okay. There are basically two types of sensors. You have discrete recorders and continuous recorders. A continuous recorder may be, for instance, if you have a buoy can collect data continuously in time. But in order to provide you the data, to deliver the data physically, you need to deliver numbers, or you may deliver a signal. The signal is continuous in time. A signal, for instance, is a graph. Like, let's suppose that you have a buoy that is floating up and down, and let's suppose that the instrument is connected to a pen that draws on a paper that is moving. Because this is an example that is significant, because in many cases it is precisely like so. So the floater is connected to a pen. The pen goes up and down, and the paper is moving slowly. So what you get at the end of the story is a graph, actually. So if this is the level age, time, and this is time, you get a graph. And this is a graph, but this kind of signal can also be transmitted in digital form. Which means that for an arbitrarily short time interval, you have a number. But actually, even when it is translated in a digital form, there is anyway a time resolution that is arbitrarily small. But still, in order to translate the data in digital format, you need to convert the continuous signal in a discrete signal. And it is arbitrarily small. So at the end of the story, from a technical point of view, it doesn't make any difference. And the result is that you get an information that is difficult to manage because you get a lot of numbers, maybe every 1/10 of a second, for instance. So you get a lot of numbers. So when you turn to the technical part, to the design, actually you don't need continuous data. You need to define a time step of interest, and you convert the data into a discrete form. And this is also what is done when you get the data in a continuous form through a graph. At the end of the story, you have to decide a time resolution, and then you convert the data in discrete form. Actually, when this conversion is done, usually you want to take the average value in the time step. So we have softwares that can sample the continuous signal and compute the average over the time step of interest. And so in this way you obtain a time series. And this is what you usually get when you download the data. And when you download the data, you get numbers. Numbers, you know, they cannot be infinite, and therefore they refer to a discrete time interval. I hope did I reply to your question?
Yes.
It's clear? Okay. But from a technical point of view, you know, usually we assume implicitly that we refer to a discrete time step, and we just talk about time scale to mean this time step. So sometimes I say, for instance, I need data at daily time scale, which means that they are sampled over 24 hours. Or I may say I need data at a 5 minutes time scale. For wave behaviors, usually we refer to small time steps, like 10 seconds, 5 seconds. So basically the signal can be, at the origin usually it can be either discrete or continuous. But in any case, even if it's continuous, it's translated in a discrete form. Okay? Other questions related to monitoring? Saltwater intrusion. Saltwater intrusion is a big issue, and it's an extremely important issue. What happens here? It happens that when you get to the interface between land and sea, salt water may infiltrate into the land. And this infiltration occurs if the land is permeable. So typically it occurs when you have a beach. If you have a cliffed coast, a rocky coast, usually you are not concerned by saltwater intrusion. Unless you are in a karst area, unless you feel that there may be cracks where salt water can get into the land. You are concerned by saltwater intrusion when salt water can get into the land. And it can get into the land usually through permeability, through infiltration. Of course, you may have saltwater intrusion also due to extreme event or to flooding. Like, suppose that you have a huge storm, even if the coast is not permeable, you may get the land flooded by saltwater. Or a tsunami. The tsunami is a very good example. So once the land gets flooded by salt water, you have a contamination by salt water of the land. It may happen through infiltration. It may happen because in the land you have lakes that become salted because of the contamination of salt water. You may have in the land wells. You understand what wells are? Wells is pozzo in Italian. Does everybody understand? Do you understand what is a well? A well is a hole in the land from which you take water. Okay? And I hope the pronunciation, I think the pronunciation is well, but anyway, I think we understood each other. Okay, so you may have contamination of wells due to flooding. This is due to exceptional cases. Coastal flooding is not a usual event. It's not something that happens frequently. It's an exceptional case. But in a normal situation, in an ordinary situation, again, we can have saltwater intrusion through infiltration. And keep in mind that usually when you have beaches, you have loose material. Loose material is porous media, and we can have infiltration. Infiltration of salt water is a big problem because you know that where there is salt water, we don't have growth of vegetation. And you know that salt water is like a poison for humans. Salt water cannot be used for human purposes. Even for washing the car cannot be used. Even for washing ourselves cannot be used. Even for flushing the toilet cannot be used because it's very corrosive and for the human health it's very, very dangerous. You know that one thing that people say in order to avoid the risks given by the sea is never, never, never drink salt water even if you get very thirsty because it brings you to death very rapidly. So salt water is a bit of a problem. So if you get salt water into the land, it's a problem, unless you are prepared to leave the land. Actually, in the land, usually we have human activities. Human activities means that we need water, and we need water, we need fresh water. And usually we take water, okay, we can take water from a water supply system through pipes, and in this case, we may say that we don't care about saltwater intrusion, but still, in the land, we need to cultivate something. Because usually agriculture, it's one of the main reasons for humans to settle down in an area. And keep in mind that often we get water from the wells, even in coastal areas. And therefore we have to make sure that the water that we take from the wells is not salted. So what does it happen when you are at this interface between the land and the ocean? So you have the land that is turning into seabed. Keep in mind that very often the slope of the land, especially when you have beaches, the slope of the land at the interface with the ocean is very low. It's very mid-slope. It's not very steep in most of the cases. Of course, we have some cases where we have a rocky coast and the land is steep close to the ocean. But if you look at the Adriatic Sea, this is not the case. And if you look at many of the beaches in Italy, many of the coasts in Italy, the slope is very mild, very low. Okay. So, if you assume that the land is permeable, why shouldn't salt water infiltrate into the land? It infiltrates. And let's assume that permeability is very large, high permeability. Salt water is supposed to infiltrate forever. Of course, you may say yes, but permeability is not so large. So permeability is indeed going up. Make this intruding flow very slow. Permeability is reduced, so the intruding flow is very slow. But still, even if it's very slow, it may take some time, but it may intrude forever. And it doesn't intrude if you get at a certain time some rocky layer. So this is the first reason. To prevent intrusion, you should reduce permeability. So either because there is a natural rocky layer, or we may build a wall here in order to reduce permeability. For instance, like a concrete wall. We may do something like this. Unfortunately, I don't remember the name in English, and I need to, will come to my mind, of this kind of intervention. In Italian it's called diaphragma. I think it's called like clog, or just 1 second. It's not easy because diaphragm is also the name of an internal component of a human body. Just 1 second. It's blocked. It's blocked. I'm not sure it's blocked. No, it's not blocked. Anyway, I'll find it out. Just 1 second, or let me see. It's not okay. I need to check. And anyway, this is. I think you understand what is this. Basically, you excavate in the land and you put concrete into that in order to build just a wall underground that stops the intrusion of water. And this is also built in order to protect some infrastructures sometimes from infiltration. Okay, this is a possibility. Actually, let's forget about it for now, because it's something that we will discuss later. Actually, there is a natural way with which the environment tries to oppose to saltwater intrusion. And I think that, you know, I'm using the right word. Basically, nature, to be in equilibrium, otherwise it wouldn't exist, nature tries to compensate for disturbances. And therefore, nature has some own ways to oppose to saltwater intrusion, which is dangerous for the ecosystem. And the way to oppose, to balance saltwater intrusion is a freshwater flow. So if you have infiltration from the land of fresh water, here, fresh water collects into an underground water body, which is upper limited by a water table that degrades toward the sea. Degrades because water that is collected on the land, infiltrated over the land, is at higher elevation with respect to the sea, and therefore in the underground tends to flow towards the sea. So you have this flow of water, of fresh water, towards the sea. And this flow of fresh water pushes back the salt water. So salt water, basically, the limit of salt water doesn't behave like this because it's pushed back by the fresh water, and we get a behavior like this. So fresh water, again, pushes back salt water. And this confrontation takes into account the fact that fresh water is lighter than salt water. And therefore you need more fresh water in order to push back salt water, because it's lighter. We spoke about the specific weight of salt water. It's higher than the specific weight of fresh water. So we have to study this kind of interaction. Keep in mind that where you have permeability, you may have saltwater intrusion, but where you have permeability, you have also infiltration of fresh water. And therefore you have flow of fresh water towards the ocean. And therefore you have this interaction between fresh water and salt water. It's an interaction that is very beneficial to humans because, of course, they can have a reserve of fresh water to use. So this is You may say, yes, but do I have enough infiltration here to push salt water back? This is the key of the problem. We have to understand if fresh water is strong enough to push salt water back. And this is just a pressure game. We have to start the pressure of fresh water. Keep in mind that the motion here is very slow. So this is basically static conditions. We don't have to deal with hydrodynamic pressure. So the pressure that comes from the fact that water is rushing. It's just hydrostatic pressure. Pressure that comes from the fact that water has its own weight. You understand that pressure of water may derive from dynamics, movement, water that is moving and then presses, and statics, water that waits. And here is just a pressure, a hydrostatic pressure game. We have to study the pressure of fresh water, the pressure of salt water, and their interaction. And what dictates pressure? Height. I just told you that pressure is equal to specific weight, and we cannot change it, times height. So it's a game that is played, is a confrontation that is played in terms of levels. We know the level of the sea, but we know that it's changing. There might be sea level rise, there might be tides, there might be storms. Storms, tsunamis, sea level that increases, pressure of salt water that increases, and intrusion that goes into land. And we need to study the level of fresh water. And you understand that if we, in a way, disturb the level of fresh water, we can have a consequence in terms of saltwater intrusion. And to be very specific, if we take fresh water from underground because we pump it, of course the level of fresh water decreases. And therefore, if here you decide one day to dig a well here, and you take water from it, fresh water, what happens here is that you have a decrease of the level of fresh water. And if you decrease it, what may happen is that the level of salt water increases. And finally, you get salt water into your well. And once the well is contaminated, you have to just leave it. Because in principle, it's possible to clean the porous media, but it takes a long time. Some people tried, and sometimes they succeeded. How can you clean this well? You can clean it by putting a lot of fresh water into the well. So you push salt water back, and you wash the medium, the porous media, by washing out the salt by using a lot of fresh water. This is a way to remediate a porous media that is contaminated by salt water. So we have to understand two things. First, how this interaction takes place. Second, we have to understand how it may evolve after human impact and the impact of natural hazards. Sea level rise, tsunamis, storms, etc. This is really a big issue. This is a big problem worldwide. If you look on Google and you search for saltwater intrusion, you find a lot of information. And you find a lot of concerns. Because indeed our experience suggests that it's a real problem. So let's understand what are, I think these graphs are very nice. These are the drivers, natural one. Let's look at this first graph. These are natural drivers of saltwater intrusion, depending on the temporal scale and the spatial scale. It's very nice. Temporal scale from 10 to the power of 4, 10,000 years to 1 year. So the time scale is ranging from 1 year to 10,000. And the spatial scale is ranging from about 10 to the power of 4, 10,000 square kilometers, so half of an Italian region, more or less, to global scale. And you see the drivers, and I think that these are self-explaining. So we may have tsunamis. Usually tsunamis act on a quite large spatial scale, but the time scale is very small. These are pulse events. Okay? They take place in a few seconds or a few minutes. And then you see hurricanes, drought. Why drought are concerning? Because they reduce infiltration. So if you have less rainfall, of course, you have saltwater intrusion. And then subsidence. Subsidence, it's indeed a big problem. And for instance, here, in our coastal region here, we are concerned by saltwater intrusion that is mainly originated by subsidence. Subsidence is lowering the level of the land, and this lowering may be due to natural consolidation of the land, or to extraction of oil and gases, for instance, or extraction of water. If we pump a lot from the underground, of course, we have the land that tends to settle down. And then there are climate oscillations. Climate oscillations, okay, we distinguish between climate change and climate oscillation. As we will see, when we say climate change, we usually imply human-induced climate change. When we say climate oscillations, we usually imply climate variability. Okay? And this is a natural fact. Climate oscillation is a natural fact. Here you see climate change. Climate change here is placed among the natural factors because, you know, climate change is a long debate. Climate change is man-induced or is